This is Parker Solar Probe, and it's going to be humanity's first mission assigned to touch the sun. It will fly to within 4 million miles of the sun's surface, confronting brutal radiation and temperatures that can reach 1 million degrees Fahrenheit.
NASA's Parker Solar Probe did the impossible. It touched the sun and lived to tell the tale. This daring spacecraft flew through the sun's blazing hot atmosphere, with temperatures exceeding 1 million degrees Celsius. So how did Parker survive this inferno without melting into a puddle? Grab some sunscreen because we're about to dive into the cutting-edge tech behind this epic solar mission. That's the incredible technology behind NASA's Parker Solar Probe. This groundbreaking mission has revolutionized our understanding of the sun by venturing closer than any spacecraft before. If you want to stay up to date on more epic space innovations, hit that subscribe button and ring the notification bell. All right, first things first. Let's talk about the solar corona that Parker was cruising through. This outermost layer of the sun is a mysterious place. Temps in the corona can hit a blazing hot 1 million degrees Celsius, making it way hotter than the surface of the sun. But here's the twist. Even with those insane temps, the corona has very low density. There just aren't a ton of superheated particles floating around out there, and this is where a key physics concept comes into play. The difference between temperature and heat. Stick with me here. Temperature measures how fast particles are vibrating, but heat depends on how many particles are actually present to transfer energy. So even though those particles in the corona are moving incredibly fast, there aren't enough of them bumping into the spacecraft to transfer massive amounts of heat. It's like sticking your hand in an oven versus a pot of boiling water. The oven may be hotter, but the boiling water has more particles to burn your skin. Make sense? For the Parker probe, the corona's lower density meant it encountered way fewer scorching hot particles. So despite the sky-high temperatures, the probe didn't gain as much heat as you'd think. This creates almost an illusion of insane heat rather than actual fiery Armageddon conditions. And that's what allowed our intrepid solar explorer to survive its wild ride through the sun's outer atmosphere. Of course, even with the corona's funky physics, Parker was still cruising through some blistering heat. So how did its delicate instruments not fry up faster than eggs on a summer sidewalk? Well, our sun-touching pioneer was packing some seriously tricked-out tech, starting with its insane heat shield. This tough shield was made of thick carbon composite foam sandwiched between two carbon plates. NASA engineered this 4 and 5 inch thick shield to withstand temps over 1600 degrees C, and it did its job beautifully, keeping the probe's sensitive electronics chill at around 30 degrees C, despite the solar inferno raging outside. But how exactly did it work? Well, the shield's clever design allowed it to reflect, refract, and radiate away much of the intense heat it encountered. Those angled carbon plates acted like mirrors, reflecting a lot of the solar energy before it could penetrate the craft. It's like having a built-in mirror shield bouncing away the sun's blazing wrath. Plus, the plates were able to redirect photons as they passed through the material, refracting them rather than absorbing all that heat. So, instead of being absorbed, the light waves were bent away. Crazy stuff. And then there's radiation. As the front of the shield did heat up from the sun's immense energy, it was designed to slowly radiate that energy back out into space. This created a balance, dumping heat buildup before it could overwhelm the craft. It's like having a personal AC system and reflective sunshade ingeniously built right into the spacecraft structure. Really genius stuff. But the shield wasn't just high-tech, it was tough too. We're talking about braving insane temps and radiation levels here. So NASA made sure to harden it against the hazards of space travel. The carbon composite foam underwent rigorous testing to optimize its durability. And the final flight shield was actually made thicker than planned to give it extra strength. When your mission is to touch the sun, you gotta come prepared. And thanks to this robust thermal protection system, Parker was able to journey deep into the sun's atmosphere unharmed. Our little robotic explorer was definitely built solar tough. Parker's heat shield tech was definitely clutch, but that alone couldn't protect the probe from the sun's wrath. NASA also hooked up some ingenious wiring and cooling systems to keep things chill. For starters, Parker's wiring is made of niobium, a metal with a crazy high melting point of 2470 degrees C. That means these wires can take way more heat than your average copper cables. To add even more insulation, NASA meticulously grew sapphire crystal tubes to encase the niobium wires. Sapphire is not only super durable but also heat resistant. So those wires were locked away safe and snug despite the extreme temps. But the real masterpiece of engineering is Parker's water cooling system. That's right, good old H2O is keeping this probe from frying up. See, Parker uses solar panels to stay powered up, but as it circles closer to the sun, those panels run the risk of overheating. So NASA created a closed-loop water circuit that absorbs excess heat from the panels. This cooling line circulates a single gallon of water behind the solar arrays. As it flows, the water draws heat away from the panels. Then it dumps that thermal energy into a radiator, which beams the heat back out into space. This keeps the panels running at peak efficiency, even in scorching temps exceeding 600 degrees C. Pretty wild, right? It's like NASA installed AC for the probe's solar system. Between the advanced heat shield, specially engineered components, and water cooling tech, Parker was equipped to handle the sun's heat. This meticulous thermal system design let the probe touch our burning hot star and survive to tell the tale. All right, let's chat about one more ingenious part of Parker's solar surviving toolkit, its smart sensor system. You see, Parker wasn't just diving blindly towards the sun. It was actually carefully maneuvering and orienting itself along the way using some very clever tech tricks. The probe has 7 tiny sensors around the edges of its heat shield. These sensors are on the lookout for one thing: sunlight exposure. If they detect any direct sunlight hitting the craft, it means part of Parker has drifted out from behind the protection of the shield. Not good. These sensors immediately send a signal to Parker's computers and guidance systems. The signal basically says, "Hey, sunshine hitting us. Initiate evasive maneuvers." Once alerted, Parker can then fire tiny steering thrusters to tilt back behind the shield again. This maneuvering keeps the sensitive instruments and wiring safely protected in the shade. It's kind of like when you adjust the visor on your cap to keep the sun out of your eyes. Except for Parker, it's automatically adjusting its whole spacecraft body, and Parker has to stay extra vigilant with its positioning. At around 10 million miles from the sun, sunlight is intense enough to fry exposed components in mere seconds. So this clever sun-spotting sensor system lets Parker continuously self-correct its orbit and orientation during its daring solar travels, keeping itself safely hidden from blistering rays. It's just one more ingenious way NASA engineered this audacious little probe to withstand its journey into the heart of the solar system. And there you have it, friends. The insane tech that allowed our audacious Parker probe to touch the sun and live. From its tricked-out heat shield to some supremely smart cooling, this craft was engineered for solar success. Which Parker tech impressed you most? The shield, wiring, or cooling? Would you volunteer to fly through the sun's atmosphere? What's the biggest engineering challenge for sun-touching crafts? What extreme environments should we explore next? Venus, Titan? Have questions about Parker's epic engineering? Ask below. Let us know in the comments what you want us to cover next right here on Spected Cosmos. And don't forget to hit that like, share, and subscribe.